Hello, and welcome back to Inclusive Design 24, 2023, brought to you in partnership with our Platinum supporters, Google and Intopia, and our Gold supporters, Barrier Break and Tetralogical. A reminder before we begin that ID24 is a respectful community, and you can find our code of conduct on the Inclusive Design 24 website. You can also follow us on Mastodon, and if you have questions for the presenters, you can post them using the ID24 hashtag or post them in the YouTube chat for our Q&A at the end of the session. Now delighted to be joined by my guest host, Stuart, the lovely and talented Stuart Hay. Over to you.
Thank you, Eric. I've been having a lot of fun with you over the last couple sessions. It is my immense pleasure to be introducing Manuel Matuzovic and his presentation on accessible web components with a question mark. Manuel, over to you.
Thanks a lot, and good morning, good afternoon, and good evening, ID24. Thank you so much for having me. It's such a pleasure to be back again. My name is Manuel Matuzovic. I'm a front-end developer from Austria, and I specialize in HTML and CSS. But I also write JavaScript as a front-end developer. And especially in the last year or so, I wrote a lot of JavaScript. And that's because with one of my clients, we decided to port their pattern library, their front-end code from native HTML, CSS, and JavaScript to web components. And we did that because we were in a meeting with a team that was supposed to work with our pattern library, and they told us that they can't work with it. And I was really surprised because I thought that we picked the most universal and most compatible language possible, HTML. So it should work with any framework, a content management system, or any web technology. It should just work. But they told us that they can't work with it because for every component that we've written, they would have to write a wrapper component in React. And my initial thought was, well, then just don't use React and live a happier life. But of course, I didn't say that out loud. And I kept listening, and I thought a little bit about what they said. And I realized that I actually had the same problem, or I faced the same problem earlier, because we wrote our component library using a static site generator called Eleventy. And if we build a website with Eleventy, we're like extremely efficient. It's a matter of hours to build a website. So we're really quick. The user experience is great. The developer experience is great. Everything is just perfect. But at some point, we used our components in a PHP-based content management system called Craft. And Craft uses Twig as a template language. And in order to make our components reusable, we had to build wrapper components in Twig for our Craft content management system. It was worth the effort because we do a lot with Craft, so it just made sense to make those components, but we had to invest some time. Then we built another website using WordPress, and we knew that we're only going to build a single website. There won't be any other website that we have to build with our pattern library, so we didn't invest much time. We didn't make our components reusable. We just, threw the code in there, and we had some redundancy, but it was fine. And talking to those web developers, I realized that we have a problem because we have our Eleventy websites, which work great. We have our Craft websites, which now also work great. But now we have React, and maybe next week someone will tell me that they want to build a website using Vue or another JavaScript framework or another content management system. And then they would have to write wrapper components, which of course is a lot of work, and there's a lot of redundancy, and it's very error prone. So back to the meeting. In the meeting, I asked, okay, what do you suggest? And then someone said, we could use web components. And I was like, yeah, no, maybe, I don't know. I knew what web components were, but I didn't have a deep knowledge of the topic, and especially not regarding accessibility. So I said, you know what, give me a couple of days. I will do some research, and then we meet again, and then we make a decision. So I took a couple of days. I did some research. I had a lot of questions, as you can imagine. And thanks to some friends like David Darns, thank you, David, I was able to answer most of those questions, and also a lot of them regarding accessibility. So we got back together in a meeting, and we said, let's do it. Let's try web components. let's rewrite our front end. And that's what we did the last year. And if there's one thing that I wished I had when I started, it would be a catalog of the most important questions regarding web components and answers to them, and especially regarding accessibility. Unfortunately, that resource didn't exist back then, but it does now because I wrote it, and that's why I'm here. I want to present to you the most important questions from this catalog. Not all of them, because there are too many, but the most important ones regarding accessibility. And since this is a catalog of questions and answers, I also decided to design this talk in a Q&A format. So I will ask a question and then I will answer this question. Let's start with an important question, which is, what are web components? Because there's no point in talking about web components if we're not all on the same page. Let me just quickly, not really quickly, I will spend quite some time to explain web components, because we need the knowledge of how they work and what they are in order to understand some of the accessibility issues that come with them. So what are web components? Web components are a set of web APIs that allow you to create fully featured custom elements in HTML. And in order to do that, you can use a couple of APIs. There is custom elements, Shadow DOM, ES modules, HTML templates, and element internals. And the only API that's really mandatory, the only one that you need, is custom elements. And like the name says, custom elements enable you to create custom elements. Now, some of you might be thinking, well, why do I need an API to create a custom element? I could just, write a start tag and an end tag, put some content in between, and I have myself a custom element. For example, if you wanted a Star Wars element, you just write the Star Wars start tag, you pass some content like Luke Skywalker, and then you have your Star Wars end tag, and that's it. And you can take this tag even in CSS, select it, select the Star Wars tag name, set display to block, add a 4-pixel blue border and some padding, and that's it. You can do that. There are some rules regarding the naming. So one of them is that your custom tag name must include a dash in order to make it possible to differentiate between native elements and custom elements. But actually, that's just all you need. And the result looks like this. So you have an element with a blue border, some padding, and so on. And it says Luke Skywalker. The thing is, an element like that is called an undefined element because the HTML parser doesn't know anything about this element because you just made it up on the spot. And it's not really useful. It's just like a div. It's pretty dumb. It can't do much. It just displays content. You can style it, but that's pretty much it. But if you define an element, you can do much more. And in order to define an element, you have to write a constructor class. So we will call this class Star Wars. It extends the HTML element DOM interface, and it has a constructor class. That's basically all you need. And then you have to define it. And you can do that by calling the define method on custom elements. You pass 2 parameters. The first one is the tag name. So in our case, star-wars. And the second parameter is the name of the class you just created. And then you got yourself a defined custom element. And it will still look the same. It's pretty much still visually still the same thing and also semantically, but now you can do much more. For example, you get a bunch of lifecycle methods that you could use. There's one called connected callback, which runs when the component gets added to the page. Or there's one called disconnected callback, which runs when you remove it from the page. Or another really useful callback method is called attribute change callback, which runs every time an attribute changes. And it gives you the name of the attribute, the old value, and the new value. So if we want to improve our Star Wars component, we could remove the text that I added manually and use the character attribute, which I also made up instead, and pass a value like Luke. And then in my attribute change callback function, I will call the Star Wars API. Yes, that's totally a thing. I will call the API and I will search for the string that I passed, and then it will give me some additional data. Let's see how that looks like. So I'm adding this tag to my page. It searches for Luke, and then it gives me the full name, Luke Skywalker. The hair color is blonde, and the eye color is blue. Cool. If I now inspect that, you can see my Star Wars tag, and the character is Luke. And if I change Luke to, let's say, Jar, it will give me Jar Jar Binks. Hair color, none, of course, and eye color, orange. Nice. If I remove the tag from the page and look at the console, you can see how it logs disconnected. So the disconnected callback function kicked in. So there are a bunch of useful things that you can do. You inform the HTML parser about your custom element, and then you have these lifecycle methods and so on. That's the first API and the only really important API. The second one is Shadow DOM. The Shadow DOM enables you to attach an encapsulated DOM tree to your custom element. Before I explain why that might be useful, let me quickly explain what the DOM is. Just a quick heads up, this definition of the DOM is probably not 100% accurate because I'm not a JavaScript guy, but it's good enough for the context of this talk. When you create an HTML element, it's basically just a text file with some special characters and text. Only when you open it in the browser, it will be turned into a web page because the browser's HTML parser takes your text file and turns it into a tree-like representation of your document. And this tree-like representation is called the DOM, the document object model. It contains all the nodes and the relationships between nodes and some properties for those nodes and so on. And this tree applies to the whole document. And you can use JavaScript to manipulate it and retrieve data. For example, you can query it and say, give me all the buttons on the page. And with Shadow DOM, you can create smaller trees that you attach to specific elements. And these smaller trees are encapsulated, which means that if you run a query on the document, the elements in those smaller trees don't participate in that. And also, if you modify the larger tree, it doesn't affect the smaller trees because the DOM is encapsulated, and that can be really useful. Let me give you an example. Here is a component called custom button, and it creates the button element. And inside it, I'm attaching a Shadow DOM, and I do that by using the disattach shadow function. That creates a Shadow DOM. Then I use document create element to create a button. I give it the text, an accessible name, and then I append it to the shadow root of the component. So not to the component directly, but to its shadow root. And this is the result, a good old button. It just looks like a button. It's nothing special. If I inspect it, you can see there is the button element, and you can also see that it has a shadow root. Let me just quickly zoom in a little bit. It has a shadow root. You can open it. You can see the button. Fine. Now, just to visualize this encapsulation feature that I mentioned, if we have a document, and let's call the document the light DOM, so in opposition to the shadow DOM, if we have a document and we have 3 native buttons and our custom button component, and we use document query selector all to find all the buttons on the page, and we return the length, we get 3, although there are 4 buttons on the page, because the button in our custom element, which is in the shadow root, is encapsulated from the rest. So we just get the 3 buttons that are in light DOM, but not the last button. Or if we select all the buttons on the page in CSS and try to style them, it only affects the first 3 buttons, because it's not just the DOM that's encapsulated, it's also the styling that's encapsulated. So only the buttons in light DOM are affected by our styling. Now, this can be a feature or it can be a bug. It depends on how you see it. A lot of blogs and frameworks will tell you that the Shadow DOM is one of the most important feature of web components, and it makes the web component and it's the unique selling point. And I have to wholeheartedly disagree, because after a year of working with web components, I can say that Shadow DOM is a nice feature. It can be useful. But I wouldn't default to using the Shadow DOM, because there are a lot of downsides for using Shadow DOM, and I've summarized them on my blog in a blog post called The Pros and Cons of Using Shadow DOM and Style Encapsulation. Again, it can make a lot of sense to use them, to use Shadow DOM, but if you ask me, it shouldn't be the default. Anyway. The next API is AES modules, nothing too special about it, just the fact that you can also export a class and then you can import it inside of a module if you want to work like that, or if you're in a very JavaScript heavy environment, then it makes sense to use exports and imports, I guess. The next thing is HTML templates, and HTML templates are really cool. If you remember the custom button component that I just showed, In the component, I use document create element to create a button element, and then I appended it to the shader root as a component. If you have one element or maybe two elements, that's fine. But as soon as you have multiple elements and also nested elements, it can get quite messy to create all your elements in JavaScript because you have to write a lot of code just to create a bunch of HTML elements. And this is where the template element comes into play because it's really, really cool. If you use the template element and you write HTML inside the start, between the start and the end tag, the code that you write won't be rendered on the page. So it's not visible on the page, but in JavaScript, you can access the template, you can extract its content, clone it, and then attach it to your component, which means that you don't have to write your HTML in JavaScript. You can just write it in HTML, and you use this as a boilerplate that you clone and attach to your component, and then you can work with it. That's really convenient. By the way, this is not specific to web components. You can also use it with, in quotes, regular JavaScript. All right, and the last API that can be really useful is element internals, which allows you to get some of the internal data that comes with form associated custom elements. I will talk about it in a couple of minutes. Okay, so these are the APIs that can be really useful when you work with web components, and I hope that you now have a basic idea of what web components are. And I assume that some of you are now thinking, wow, that's a lot of JavaScript that I have to think about. And this sounds like we're absolutely 100% in JavaScript territory. So this is nothing that I want to use because I don't build websites using JavaScript. So the first question that might arise, or the first question that I had is JavaScript a dependency? Because if JavaScript is a dependency, I definitely don't want to use web components, because there is no way that I'm going to have a dependency on a language as fragile as JavaScript. So is JavaScript a dependency? It depends. It depends how you build your components. Let's say we have the message component, which just shows a message. It can be an information or a warning or an alert. For my component, I have the message start tag, the message end tag. I have a type attribute to define what kind of message it is, and then I have a text attribute to show some text. In this case, it says that's a warning. Inside my component, I'm in the attribute change callback. I listened to changes to the text attributes, and whenever it changes, I write the contents to the component. Cool. So that's what I get. Just an element with an orange border that says that's a warning. If I disable JavaScript here, you can see it's gone. And it makes sense because I'm passing content using an attribute, and then I'm using JavaScript to extract the data from the attribute, and I'm using JavaScript to write the content to the component. So if you build your components like that, yes, JavaScript is a dependency, but you don't have to do that. You can also, instead of using an attribute, you can just pass your content to a component by inserting it between the start and the end tag. And this process is called slotting. So you can just slot content to your component. So on screen, you can now see that I'm not using the text attribute anymore, but I'm just writing the text between the start and the end tag. And in your component, in order to make this work, you have to create a slot element in HTML and then append it to your shader root. The slot element, basically what it does, it takes the content that you pass from the light DOM and then displays it in your component. Now, our component still looks the same, but the advantage here is now if I disable JavaScript, we still see the content. You can see that the styling is gone and all the functionality, of course, because now we don't have any JavaScript anymore, but the content is still there. And that's possible because the content lives in the document. It lives in the light DOM. We're passing it from the document to the component. And for me, as someone who strongly believes in progressive enhancement, that was great news, because that's a really nice way of progressively enhancing components. Like I can provide a base functionality, base content for my component, and then in my for my component, and then inside the JavaScript of my component, I can enhance it. And I just quickly want to inspect it so that you can see how that looks like. So without JavaScript, it's just a custom element, an undefined custom element, and it basically just shows the text. That's it. And if we enable JavaScript again, we of course get the shadow root back. So that's the difference. That's how you see the difference. And inside my shadow root, you can see there is my slot element and some styling. Nice. And there's another way of creating custom elements, and I really, really like it. It's super cool. So we have the message component again. We're again slotting content. So that's the same. The only thing that's different now is that now, in addition to the content that we're slotting, we're also adding a template tag. And inside the template tag, we have the styles for our component and a slot element. So I'm not using JavaScript to create the slot element, but HTML. And this templates tag is special because it has a shadow root mode attribute, which is set to open. And this attribute attaches a shadow tree to the component, where on the server, not on the client. So we don't need JavaScript to attach a shadow tree. And how is this special? Well, if we have JavaScript, our component just looks like it did before. And if I disable JavaScript, it still looks the same because we've attached the shadow tree declaratively in HTML. And if I inspect this, now remember JavaScript is disabled here, you can see there's still a shadow root. And this is really cool because it allows you to create web components that work on the client without JavaScript, or on the server, sorry, without JavaScript. Okay, so what's the catch? Well, it's not supported in Firefox, unfortunately. Even Safari is supported, starting with 16.4, but there is no support in Firefox. So I guess the next question is there a polyfill for declarative shadow DOM? And the answer is yes, kind of, because you can make it work in Firefox and all the other browsers that don't support it, but JavaScript is a dependency. And the polyfill is pretty simple. You just find all the templates tags with the shadow root mode attributes on the page. You attach a shadow DOM to the host component programmatically using attach shadow, and then you just append the template content to the component, and it works in Firefox. The only downside is that JavaScript is a dependency. All right. I just told you that there is this thing called DOM encapsulation and style encapsulation. So the DOM and the style don't participate in whatever is happening in the document. So I guess a fair question is, can I tap to an element in Shadow DOM? Like, are there any other constraints? And the answer is yes. Let's say we have the button component again. We attach a shadow tree, we add a button, and we add a click event to the button. And I can just use the keyboard, I can find the button, I can press enter, I can press space, it just works. So there are no limits to that. So just because the DOM is encapsulated, it doesn't mean that any functionality of the elements you're using are encapsulated. So that's fine, it works just as you would expect it. Next question, can I focus an element in Shadow DOM programmatically? So not tabbing to it using the keyboard, but can I use focus if an element is hidden inside the shadow tree? And the answer is yes, you can do that. So again, if you take the button component, we have our button inside it, it's attached to the shadow tree. Then we can find the button inside the shadow tree from the outside in the document. The only important thing that you have to do here or to consider is the shadow tree has to be an open tree. So when you use the attach shadow function, you can see there is one option I'm always using, which is mode, and it's set to open. This creates an open shadow tree. There's also a closed shadow tree that most people don't recommend because there are a lot of downsides of using it, and usually you default to the open shadow tree. And the option that I'm presenting now only works with open shadow trees. So that's the only important thing you need to know. It only works with open shadow trees. So how do I find an element inside a shadow tree of a component? Well, you select component. So here I'm running document.querySelector. I'm finding the button component. And then in order to access elements inside the shadow tree, you use .shadowroot. And then you can use querySelector. You find the button or whichever element you want to focus. You use the focus element and method, and it just works. So let's say we have two buttons. One button is in the document in the Light DOM, and the other one is in my custom component. I press the button in Light DOM, and you can see how focus is on the button in Shadow DOM. So that works. There's also another option of doing it. So when you attach the shadow DOM to an element, you can pass another option, which is delegates focus. And if you set delegates focus to true and you focus the host element, or the custom element, it will delegate focus to its first focusable element. So with delegates focus true, I can now just directly use the focus method on my custom element. And now it will delegate focus to the button. So again, there's a button in LightDOM. There's one in my custom component. I press the button in LightDOM, and you can see how it delegates focus to its child item. Okay, so all that works. So that's good news. Now it's time for some bad news. The next question is, can a skip link target an element in Shadow DOM? The answer is no. Let's say we have two anchor links. We have one that points to a paragraph in LightDOM and one that points to a paragraph in the Shadow DOM of a custom element. The first anchor link works, so I can target the paragraph in LightDOM. That's fine. The second anchor link doesn't work because IDs are scoped to the shadow tree. So the ID that I created inside my shadow root here in my component doesn't exist in the LightDOM. It doesn't exist in the document. It's encapsulated, it's scoped to the shadow tree. So all the elements in my document don't know anything about the IDs in shadow trees. So you can't focus, you can't target an element inside the shadow tree. Of course, if you put the ID on the component itself, it works because the component itself is in the document in the LightDOM, but you just can't find elements in the shadow DOM. So I guess the next question is, can I connect a label in LightDOM to a form element in shadow DOM? And the answer is, it depends. Actually, the answer is no, but it depends on how you use your components. So let's say you use your components like that. That's the progressively enhanced way. So your label is in a document and you pass your form element to the component by slotting it. So from the LightDOM to the shadow DOM. This works. Why? Well, because the label and the input element are both in the document, they're both in the LightDOM. So the ID for relationship works. But if your label is in the document and your input field is in the shadow tree of your component, then it doesn't work. Why? Well, again, because IDs are scoped. The ID of your input element is scoped to the shadow tree, and the for attribute can't find the ID because it doesn't exist in the document. And that sucks. And it even doesn't work if you're using the Clavity Shadow DOM. So even if it looks like you're working in LightDOM because you're writing all your elements inside the template tag, inside your component, still you're using Shadow DOM here. So all the IDs inside the template tag with the shadow root modes attribute are also scoped. So that doesn't work either. If you try to label it implicitly, so if you put your custom element inside the label tag and try to use implicit labeling, it won't work because implicit labeling only works with labelable. Is this a word in English? I don't know. With labelable elements. So button, input, text area, select, progress, meter. Did I forget anything? I don't know. So it only works with these elements and with form associated custom elements. And this is where the element internals API comes into play. You can make a custom element form associated by setting form associated to true. And then you can use the element internals API and get access to some of the internal information. So if you're using a label element to label a custom element, you can access the elements that have labeled your custom element by using the attach internals method. And then, I don't know, you could just use this information and provide an accessible name for your input feed using ARIA label. So you can give it an accessible name, but you're not properly labeling it still. But that can be a solution, I guess. Yeah, pretty messy. That's a problem. Next question. Can I create an ARIA reference to an element in Shadow DOM? No, unfortunately not. Again, because IDs are scoped. So let's say you have a label element and you have a date input field. The label labels the input field because they're both in the light DOM, so that's fine. But you also want to provide a description for your input fields, and you use aria described by, and it points to an ID in a custom element called the hint. And the hint just contains a paragraph with the ID hint, and inside it says, here's the date format, the only date format that makes sense. So day dot month dot year. And you try to describe the input fields with that information. Of course, it doesn't work. Well, why? Because the ID is scoped to the shadow tree. A solution for that might be aria mixins. So for every aria attribute, you also have a property in JavaScript. Like for aria labeled by, you have aria labeled by elements. For aria described by, you have aria described by elements, and so on. What's useful about the JavaScript property is that the attributes like aria labeled by expect an ID, but the property expects an element. So while you might not have access to the ID, you might have access to the element itself. So inside our component, we could just select the input field, select the hint, and on the input field, we use aria described by elements, and we provide a value, which is an array because an element can be described by multiple elements. And then we list all the elements that we want to use to describe our input fields. So in this case, we would use the hint custom component, find the shadow root, and then inside it finds the element with the ID that provides the description for our input field. That sounds great, but there are some limitations to that. This only works if both elements are in the same shadow root or if they're in some kind of ancestor relationship, which in this case, it's not the case. So this doesn't work, but it could be a solution in certain scenarios. And it's basically the only solution we have for this particular problem. But there might be help sometime soon, who knows, or sometime in the future. There are two proposals. One of them is cross-root aria delegation. And the idea of cross-root aria delegation is that when you attach a shadow DOM, you can define all the attributes, aria attributes that your host component delegates to your child components, child elements. So inside the attach shadow methods, inside the options, I could say delegates aria attributes and then list all the aria attributes like aria label or aria described by. And then inside my component or on my component, I would use aria label and aria described by, and those attributes will be delegated to all the child elements that want to consume them. And those elements that want to consume them, they need an attribute, which is the super short attributes, delegated aria attributes. And there you list all the aria attributes that you want to take from the parent element. Of course, this is just a proposal. So if this ever becomes spec'd, it will probably look differently, but this is just the idea behind it. There's also cross-root aria reflection, which goes in the opposite direction. And the idea here is that when you attach a shadow DOM, you can define all the aria attributes that should be reflected from child item to the parent. So here I'm saying, please reflect aria active descendant. And then if you have an element like input here and you use the aria active descendant aria attributes and it points to an ID on a custom element, it would work because there is a child item inside that component that reflects its information to the parent element, and the parent element then passes it to the element that referenced it. It took me quite a while to wrap my head around that because it's very complicated, and all this is also new to me because I just started to work with web components a year ago. So if you want to learn more about that, or if you have questions about that, please ask or read information by much smarter people like the amazing Alice Boxhall. She wrote an article called How Shadow DOM and Accessibility Are in Conflict, or Nolan Lawson, who wrote an article called Shadow DOM and Accessibility, the Trouble with ARIA. Okay. Next question. Can I access a live region in Light DOM from Shadow DOM? So we just learned that it's possible to access information from the document inside a shadow tree, but is it possible to get information from the shadow tree from documents? And the answer is yes. So I have this simple component here where there's a button, and whenever I click a button, it just generates a random name, and the name is written to a live region in the document. So you can see here, I'm selecting document.query, select the output, so an output element that is in the document, and I'm writing to it. So we have our custom the button, we have the output element, and whenever I click the button, you can see how it writes to the output element. So the important information here is it's possible to write to content in other components or in the document from within a custom element. Can I create a custom element based on a native element? Yes, but so it's possible. When you usually create a constructor class for a custom element, you extend the HTML elements DOM interface, which is the basic standard DOM interface that all elements use. But you can also use a specific DOM interface. For example, you could say, create an enhanced button which extends the HTML button element. And what's cool about that is that this custom element will build on top of all the features and properties of the native button element. So you can take the button as a baseline and then just add extra stuff, which is really cool. So you extend a different DOM interface, and when you define the button, you have to pass a third parameter. The first parameter is still the tag name, so enhanced-button in this case. The second parameter is the constructor class, and the third parameter is just an object which tells the method which element you are extending, because multiple HTML elements can share the same DOM interface. For example, the block quote element and the queue element both use the HTML quote element DOM interface. So here you want to define which element are you extending. And when you use it, you don't actually use the extended button tag, start tag, and end tag, but you use the native elements. You use the button element, and then on the button element, you use the is attribute, and you set it to your custom tag name. So here you can see I'm saying button is enhanced button. And inside my enhanced button function, I could do all kinds of things. Like, for example, here I'm setting the ARIA expanded attribute by default to false. I'm attaching a click event, and whenever the user clicks the button, it just toggles the ARIA expanded attribute. And then you can create your own simple disclosure widget. So we just have a native button element. We use is to enhance it. So now it uses ARIA expanded, and then we can, create a custom disclosure widget. Yes, and that just works. That's pretty nice. And I said, yes, you can do that, but not in Safari, and Safari has no plans whatsoever to implement it. There is a long discussion on GitHub. They just don't want it. So probably never going to happen. Who knows? Okay, we're approaching the end of my talk. 2 or 3 more questions. Can web components help improve accessibility? Yes, you can use web components to enforce certain best practices. Here's an example. Let's say we have a card component. The card component is this, what I mean by card is like this very typical pattern where you have an image followed by a heading, followed by some text. And it serves as a teaser for a blog post or something like that. And visually, usually it's in that exact order. So you have image, heading, and content. And in this component, you can see that the developer was very much inspired by the visuals of the component, because the content inside my card component starts with an image, followed by the heading, followed by the content. But regarding document structure, it would make more sense to start with the heading, because the heading introduces this component and not with the image. I don't care about that, because as you can see, each of these elements has a slot attribute. And what's nice about Shadow DOM is that you are not limited to using one slot element. You can create multiple named slots. And nice thing about that is inside your component, you can decide the order. So I don't have to care about the developer and how they structure the components and in which order they provide the elements. I decide the order in which they will be output. So I'm starting with the heading, followed by the media or image, followed by the content. And this is really nice because I can enforce my best practices. So the result is a component that displays the heading first, followed by the image, followed by the content. And then I just use CSS to reorder it so the image comes first. And there are more examples where you can use web components to enforce certain best practices, but I don't have enough time for that now. Okay, next question. Are there any constraints regarding keyboard accessibility? No, not really. So it just works. There's just this one annoying thing, which is usually when you provide focus styles for a component, you do it globally. So in your global CSS, you write your focus styles, and you expect this to apply to all the elements on the page. And this is true for all the elements in Light DOM, but those styles don't apply to elements in Shadow DOM. Excuse me. Those styles don't apply to elements in Shadow DOM because, again, styles are encapsulated. So what you have to do is you have to repeat your declarations. Of course, you don't want to repeat the values. So what you can do is you can define custom properties on the root element. I'm sorry, on the root element, on the HTML element, and you just use these custom properties as the values for your properties globally, and then you reuse those custom properties inside your component, because style encapsulation isn't 100% style encapsulation, because inheritable properties like background, color, and custom properties will leak into your components. This is a feature, it's a good thing, so you can just reuse the custom properties you have defined globally. So this isn't really a problem, it's just annoying, and you have to know it and you have to consider it. Are there any constraints regarding screen reader accessibility? Yes, the clear answer here is yes, just because of all the ID scoping thing that I talked about earlier. So the problems with ID and for relations and ARIA attributes and so on. Are there any constraints regarding accessibility testing? Yes. Here is a component that I created called some bugs, and it has some accessibility issues. Like there's an image with no alt attribute, there's a button with no text, there is a button with ARIA hidden set to true. If I add this component to my page and I use XDevTools to test it for automatically detectable accessibility issues, I get 3 issues because I created those issues. So that's fine, that works. If I wave this page, I get 0 errors because Wave doesn't support Shadow DOM yet. I know that they're working on it, but at this time in 2023, it doesn't work with Wave. And I suppose that there are also other testing tools that don't support Shadow DOM. So this is one thing that you should note. So in my experience, it works with everything that's X-based. So XDevTools, Accessibility Insights, Lighthouse, and so on. The other thing that's annoying is the following. When I debug keyboard accessibility, I like to use the live expression feature in Chrome DevTools. So when I tap through a page, I always create live expression where I log document.activeElement, which gives me the active element on the page. So you can see currently I'm focusing the first button, now I'm focusing the link, the third button, second button, sorry. And when I'm focusing an element that's inside the shadow root of a component, you can see it doesn't log the actual element, but only the parent host component. So what I have to do here to work around that is create another expression where I log document.activeElement.shadowroot.activeElement, and now it gives me the host component and the actual element. The only downside here is that when I focus on an element that doesn't have a shadow root, I get this ugly error message. It's annoying, but you know, not a big deal. All right, and now the final answer, question and answer. Is it possible to build accessible websites using web components? Yes, absolutely. It's absolutely possible. The only thing is that you just have to consider certain things, the things that I talked about today. And the most important is the fact that IDs are scoped. But if you know that and you plan your architecture accordingly and you plan ahead and you consider accessibility from the very beginning, which all of you do, then it works. Then it's absolutely possible. I just did that for the city of Vienna. We're almost done. We will soon launch a website that's built on web components. We had some external accessibility testing. It all went well. I tested it. It's great. It just works. And the great thing is we can now just drop our web components into an Eleventy website, a Craft site, WordPress, React. It doesn't matter. You can use it in the same way. So it's a really nice thing. Okay, I know that was a lot and it was very technical and probably hard to process because it's a lot of new technology and stuff, and probably stuff that many of you haven't used yet. And I'm really sorry that I talked so fast, but I just wanted to cover as much as possible. If you just need some time to process that again, then I can point you to my website where I wrote this blog post called Web Components Accessibility FAQ. It includes all the questions that I asked and answered today, plus some additional questions. Thank you so much for listening. I hope that you learned something new, and yeah, please enjoy the rest of the conference, and thank you so much for listening.
Amazing. Thank you so much.
Thank you. Thanks for having me.
That's fantastic, Manuel. Manuel, I've got an initial question for you from our friends over at YouTube, from a gentleman by the name of Stefan. Stefan has asked, is there a way to reuse the template code of declarative Shadow DOM? And if I have 10 custom elements with DSD, do I have to include the same template 10 times?
I haven't used the declarative Shadow DOM yet because of this limitation that it doesn't work with Firefox. But as far as I know, yes, that's one of the downsides of using declarative Shadow DOM, that you have this repetition. So that you have to repeat the template tag 10 times if you're using it 10 times, as far as I know.
So like one in, one out kind of style.
I don't know what that means, but yes.
Okay. Yeah. Saw another question. Oh, yep. That was a thank you in the chat. I think we might have time for one more. Let me double check. Hans was asking, could skip links to Shadow DOM targets be resolved with a click event handler combined with the open Shadow DOM option to override the native browser skip behavior?
Yeah, you can use JavaScript for anything. It's like the point is that I want stuff to work without JavaScript, and just one limitation. Of course, you can work around things using JavaScript. You can move focus, or implement your custom solution. That definitely works because we can access elements inside the Shadow DOM. We know that as long as it's an open Shadow DOM. Yeah, but the point was here, like, does the native functionality work? And I use this example to build up on some of the stuff that you can't really fix, which is the ID and for relationship between a label and form elements and all the ARIA stuff.
Great, thank you. And I think there's one more if you're feeling up for it.
Yes, absolutely.
Christian is asking, with the experience that you gained, would you go with Shadow DOM again for your next project, or would you look for other methods of encapsulation?
The thing is, I didn't have enough time to go deeper into the Shadow DOM topic. I already spent a lot of basic web components, providing basic web components knowledge. But if I had the time, I would have told you that I definitely also use the Shadow DOM. So there's a use case for Shadow DOM. Sometimes it makes sense, and it's also really nice for progressive enhancement. And inside one of the questions in my FAQ, I also have an example where I show how Light DOM and Shadow DOM really play nicely together in order to create progressively enhanced components. So yeah, definitely. The only thing that I would change now is that I wouldn't default to Shadow DOM. So by default, I just wouldn't use it. And then only when I need it, when it makes sense, I would opt into using Shadow DOM. And that's like I said, that's the opposite of what most frameworks and blog posts will tell you. They will always say, use Shadow DOM. It's like the killer feature. It's a USP of web components. And I wholeheartedly disagree with that. But there is a use case for Shadow DOM, and it just makes sense. If I have just time for one more example, my friend Egor Close, who works a lot with web components, he told me that he builds this huge pattern library, and he doesn't know where his patterns will end up because a lot of teams are using it in a lot of different projects and websites. And he also doesn't know how the web components will be combined with other CSS and other JavaScript. So he just relies completely on Shadow DOM. He makes sure that wherever his components will be dropped in, they just function and look like he would expect it to do. And that's where DOM and style encapsulation can be really useful.
Yeah, that makes total sense. Great, thank you. So with that, wrap. So thank you again for such a thorough and technical session for something that sounds like it has a lot of really exciting potential, but also a lot of like benefits for the accessibility community. And for
Definitely.
doing the work to answer a lot of questions that I know a lot of people have. For those of you watching live or who are watching, if you enjoyed this session, remember to hit that YouTube like button, and you can also subscribe. Our channel page is youtube.com/inclusivedesign24 to be kept in the loop for future events. Inclusive Design 24 would also like to thank our supporters, Google, Intopia, Barrier Break, Tetralogical, Intuit, Infoaxia, and the Law Office of Lainey Feingold. And we'll be back on the hour with our next session. This will be the end of my shift and Stuart's, I believe, as well. So just to say thank you for being an excellent co-host, and we will see you real soon.
Thank you again, Manuel.
Thank you.